Hey guys, welcome back. So today we're working on this Generac XG8000e. This machine appears to be in very good condition. You know, there is no damage, no rust, and according to the clock, there's only 112 hours of runtime on it. That said though, it is missing a lot of parts. You know, it was missing parts when I got it, and I've actually stolen a few parts since I've had it to save another machine. And ultimately, I think this is a parts machine, but I've never actually gone through it to determine that for sure. That said though, you know, this machine came to me from my friend Brendan, who picked it up for 20 bucks. You know, according to the listing, it doesn't make power. So he picked it up, planning to do something with it, and ended up giving it to me. And that was about 2 years ago. You know, the only thing I did to it at the time was pull the end cover off, and what I saw was concerning, you know, as far as the power head goes, but also the engine. So I'm not sure if either is viable, but that is what we're going to find out today. So let me get you set up a little bit better and get going on this. So I've got the machine spun around, and I'm going to take this end cover off so you can see what I saw 2 years ago. And this is another reason I don't like the XG series. Simple things like this end up being a project. So we don't actually have the clearance to get the cover off. You might have to fiddle with this a bit, but I think you can see the problem here. All the wires, they are disconnected. So someone was definitely in here trying to do something. What? I'm not completely sure. So I do want to test the stator and the rotor, as well as the DPE and the sense winding, and see if this generator is any good. You know, from looking at it, it doesn't look like it melted down. So there is a chance that it is good. But the reason why I thought this was a parts machine was this right here. You know, the rotor bolt, it's not threaded in. So I tried to thread it in, and it will not even try. So the bolt, you know, I don't think it's broken, and the threads on the bolt look halfway decent. So my best guess is that someone tried to get this generator off the engine, and they didn't do it right. You know, likely they damaged the threads on the crankshaft. So even if the engine runs, you know, we can't bolt the generator to it, at least not in the condition that it's in. And given what they did to the generator, it may not be good anyway. So, you know, I say we start here. Let's get a little better access. We'll run some tests, see if there's any red flags, and we'll just go from there. I did manage to get the cover off, but look at the back side of the cover. You know, it looks like the engine was running with the bolt like it is. So I guess the question is, did this actually back off when it was running? And did the rotor slip on the tapered shaft? I'm not sure, but that is definitely not a good sign. So I'm just going to rotate the engine, maybe position you a little better to see if the rotor spins with the engine. Yeah, we have problems here. Initially, I thought we were good. You know, I rotated the engine and I saw the rotor moving. But what I realized is that if I rotated the engine quick, the rotor was very slow to start moving. And then if I stopped rotating quick, the rotor would keep rotating and kind of slow down. And when I rocked the engine back and forth, the movements of the crankshaft didn't match the rotor. So yeah, something is broken, you know, potentially the crankshaft, or maybe the rotor is no longer attached to the tapered shaft. And, you know, either one is not good. If that crankshaft was spinning in the rotor, it may have caused damage on both. Either way, I think we need to find out which it is. So we need to take the generator off and inspect the damage. But before I do that, let's just test everything, see if electrically it's still good. And then we'll take it apart and see mechanically, is it viable? So I'm thinking we'll just get probably the AVR and the brushes out of the way, as well as this wire block. If by some chance this generator is still good and we actually get to testing it, we are going to have another hurdle to cross here. The colors coming out here do not match the colors to the control panel. So it's not obvious how these should be connected. So we'll have to cross that bridge when and if we get there. All right, so let's start with the stator here. We have two legs coming out. I'm assuming the wires that are bundled are one leg and the other bundle is the other leg. So, I don't know what the value should be for this machine, but usually around 0.3 to 0.5 ohms. And yeah, we're at 0.3. That looks good. We'll check it to ground. No ground fault. So that leg appears to be good. We'll check leg 2. And same reading, 0.3, 0.4. Check that to ground. No ground fault. So the stator would appear to be good, although we do have a couple more windings over here. So the blue wires, those are likely the DPE winding. That varies a bit, usually between 1 ohm and about 2.5. So let's see if I can get the probes in, what this one's at. And we're at 2.1. So that seems reasonable. Let's check it to ground. No ground fault. We'll check it to the other legs. There should be no connections to anything else. And yeah, DPE would appear to be good. And then we have these other wires, which are the sense winding, and that usually ties in over here. It's a white and a green. So the value is probably going to be very similar to what we tested on the legs. I'm guessing around 0.3, 0.4. And in this case, we're not getting anything, but that might be okay. Sometimes the sense winding only connects to one of the legs, and other times it's actually sensing the 240, so it's tying the two together. So let's just check the black wire, it looks like. Actually, no, that's the white wire. And we'll check it to each leg, see if there's a connection. Nothing there. And we do have a connection there. So that is good. We'll check it to ground. No ground fault. And then if we go to the other wire on the sense, that should tie in to the other leg. And it does. And we already checked these leg 1 and leg 2 for ground fault. So we know that that doesn't have a fault. So the stator, at least, that tests well. So there's nothing wrong with that. Let's just check the rotor on the slip rings. I can see there is some oxidation, so it might be a little challenging to get a good reading. But I would expect a reading hopefully less than 70 ohms. And I get nothing. So that is surprising. Even though the bolt failed, I would not have expected this to be open circuit, although I say that, and I can actually see a broken wire. And that right there is the broken wire. It's actually supposed to be connected up to that terminal, which connects the rotor to the slip ring. So I'm willing to bet if we try testing from there to one of the slip rings, we should hopefully get a reading. So I'm going to try that real quick and see what we get. And now I can't get a reading. It's possible we have multiple broken wires here. So, I don't think that wire broke when whatever happened here to the bolt. These wires were tucked in. Likely the engine was rotated. And these wires, they are exposed. And if something gets in the way, they are going to break. So potentially we have multiple broken wires. So yeah, let's move forward. Let's get this thing torn apart, and we'll just see how bad the rotor is. There's only 2 bolts holding this tank on. It's supposed to be 4, but I think I stole a couple bolts for the last XG8000 I fixed. We're also missing hardware on the other side. So all that stuff's replaceable. But given what I've seen so far, I think this might be a parts machine. So it took a bit of persuasion, but we do have access to what we need. Actually, very good access. So, we're just about at the point where we can pull the stator off. The only thing holding us back now is the exhaust, because the support for the exhaust is actually the end housing for the stator. So we do need to remove the exhaust first. Just a few bolts right here on this bracket, and a couple more crusty ones going into the head. They look like Allen head screws. So we'll get those out, get the exhaust out of the way, and then we can finally pull the stator off. Not exactly sure how they expect this one to come out. You can't get a straight shot on it. And likely it's going to strip out, but let's try. So we're just about there. Just got one more bolt holding this bracket on, which is also loose. And then we need to unbolt the stator, at least the legs, from the bottom here. And I couldn't help notice at least this one is loose. And the nut is actually missing from the bottom. So yeah, someone was definitely in here. I guess what I'm wondering is, what came first? That rotor bolt, I've never seen one loosen up on its own. And both these are loose as well. So I'm going to prop this up. We'll get these mounts out of the way, and we'll use a piece of wood to support things. And I think we can remove the remaining stator bolts and get that uninstalled. The stator's going to fall right out. I don't even need a puller. At least I don't think I do. Just releasing the tension on these bolts, I saw the whole thing kind of pull away from the bell housing. Okay, while we're in, it wasn't very graceful. The engine actually tipped forward, which usually doesn't happen. The mounts on this are a little bit different. Usually they're more towards the flywheel, but since they put the mounts right there, the weight of the flywheel tipped the engine forward. And the frame, without the weight of the generator, wants to flip over. So the only thing preventing that right now is the weight of the generator on this rail. So we do need to strap things down, but I want to do that so I can move this off to the side and work to separate the ball bearing from the end housing. That way we can pull the rotor out and get a better look of it. Now, as far as the crankshaft goes, it's not terrible. I mean, it is chewed up a little bit down toward the bottom, but I'm willing to bet, this could be reused, assuming we can correct the issue here with the threads. So that's something we will look at in a bit. But for now, let's secure things, finish taking this apart, and get a better look at the condition of the rotor. I've got everything secured, more or less. It's still a little bit light, but there is enough weight to keep things where they need to be. So I've moved the generator part over here, and I'm just going to try a 2-jaw puller to separate the ball bearing from the end housing. Just going to use a little bit of PB Blaster. Every little bit helps. The ball bearing isn't difficult to separate from the end housing. The problem is the end housing is made out of aluminum. It breaks really easy. I've broken my fair share, and I don't want to break this one. Although it's a parts machine, the stator is good, and ideally we'd keep the end housing good as well. So we'll just try this a little bit of force, and you'll know pretty quickly. So right there, that's as tight as I can get it by hand, and it didn't move at all. And it is coming out. Although we're not very centered, so let me fix that. Okay, we are free. And there's the wire we saw earlier, which should be connected to there. But you can see we're a little short, although we can touch it. So there's hope. But we also have more of the same damage over here. There is a missing wire, which I assume is that one right there. But we also have another one down here, which likely was bridging these two coils. So yeah, unfortunately, this rotor sustained a lot of damage. And you can see here in the slip rings, there is a lot of corrosion. That would clean off, but I think without, enough copper to make these connections, I'm not sure we're going to be able to repair this one. And I'm also noticing we have some damage down here at the bottom. This plastic piece, it's supposed to extend all the way across, and there's supposed to be a piece right there to help support the wires. You can actually kind of see the color difference right there. So for some reason, it broke off on that side, and the other side looks perfect. But yeah, unfortunately, the rotor, it is done. That said, though, I did take a look to see if this part was still available from Generac, and the good news is it's available, but it is sold as a set. You have to also buy the stator, and the set costs over $1,000. And once you factor in tax and shipping, you're looking at closer to maybe $1,100 or $1,200. So yeah, this machine, it's not worth that kind of money. That said, though, I do have extra rotors in storage, and potentially one of them will be the right size. So I'm going to make a quick trip out there. We'll measure things up, and with any luck, one of them will fit. So we've got a few to pick from, but they have to have the right taper, the right size ball bearing, and exactly the right length. So let me quickly measure some of these up and see if we have a winner. I think we have a winner. The one in the back is exactly the right length, has the right size ball bearing, and the tapered shaft, I'm actually not sure if it's correct or not. I'm thinking let's bring it back, we'll take a closer look, and with any luck, it'll fit onto that engine. So this one isn't quite the slam dunk that I thought it was. There's a few differences. I guess first off, the height is a little bit short by about 1/8 of an inch, which doesn't sound like a lot, but that might be the difference between the brushes aligning on the slip rings and not. So we are going to have to test fit it and see how that's going to work out. Also, the original rotor, it has a twist in it, and that twist lowers THD, whereas this one is a standard rotor. So with the original, we would have had single digits THD, and with a rotor like this, I think we're going to see in the double digits. And the last issue is the fact that this one is copper as well as the stator, and likely this is copper-clad aluminum. I don't think that's going to make a difference, but I guess we are going to find out. So let's clean up these slip rings. We'll clean up the crankshaft. We'll see if this installs properly, and then we'll fit the stator and check the brush alignment. I'm just going to use a piece of Scotch-Brite to clean these up. Just be careful not to nick the wires, because as we saw in the other rotor, they are easy to break. And I'll check the resistance on this rotor too. Unfortunately, I don't know what it was on the other one. So the other concern might be too is, can the AVR power this rotor properly? Likely the resistance is a little different. That said, though, usually they all come in between 40 and 70 ohms. And given that these are approximately the same size, I wouldn't expect this one to be too different. And let's see where we're at on resistance on this rotor. Usually between 40 and 70 is what I see. This one's pretty good at 50.7. Check it for any fault to ground. And no fault to ground. So this rotor is good. Let's try the old rotor again. Let's see if we can get any reading on the meter. And assuming I can get a reading, it's likely only going to be for one coil. So I think we'd have to double that to get what the reading would be if it wasn't broken. And yeah, 23 ohms on one coil. So you double that, we're pretty close to the same reading as this other one. So this rotor actually came from a Black Max 7,000 watt machine, and I got it on trade. And at the time, I had no idea what I was going to use it on, but hopefully, even though it's a tiny bit shorter, hopefully this one will work out. So let's fix the threads, clean up the crankshaft, we'll fit this, and see if it's going to work. So let's see if we can get these threads back. These are a 5/16 24, and I did try another bolt, which I know is in good condition. And that one also will not thread in there. So, I've got a tap, and all we can do is try. Because the way it is right now, even if this engine runs, which I think it will with a little bit of work, we can't use it. So the real trick here is, are these threads that I'm putting in right now, are they making new threads or cleaning up the ones that are there? And I think, given how easy it's turning in there, I think I'm actually just cleaning up the damaged threads. So let's check it now with the bolt. Okay, I'll take that. So the crankshaft, I think, is good. So I've just been cleaning this up with this fine grit sandpaper. It's actually coming off, or coming clean, pretty effortlessly. So the tapered part looks pretty good. This is actually the only part that holds the rotor on. The rest of it isn't used. So, besides the damage right at the tip, the rest of it's pretty good. And I don't feel any burrs, but I might take a file to it just to make sure. Yeah, that feels pretty good. Okay, good. So the rotor is rotating the crankshaft, and there's no slipping. So that is a good sign. We still need to torque this down properly. Hopefully we can, given that the threads were damaged. But for now, let's get the stator on, and we'll check the brush alignment. I can tell already we're off more than I thought we were just by the position of that ball bearing. It looks like it's closer to a 1/4 inch, which is going to be too much. There's almost no way these brushes are going to align. We are so close, but unfortunately, this rotor is not going to work. I just took a look in there with the camera, and as feared, the alignment of the brushes, it's off by about 1/4 of an inch. So unfortunately, we can't use this rotor with this stator. So that brings us to plan C and plan D. So while I was in the storage locker, I also grabbed these stators. These are ones we harvested in previous videos, and I think this one from a Predator might be the winner. You know, it's rated at 7,250 watts with a surge of 9,000 watts, and the length of this stator, it's about 1/4 inch smaller than the one that's on that machine right now. So, you know, this one I think will work. So I'm going to get the bell housing and the end housing removed. We'll fit the XT8000's end housing on here, and we'll try to test fit that. Now, worst case, we do have a plan D. This is a stator from a Generac GP7500. So this stator is rated at 7,500 watts. And the interesting thing is that the length of this is actually a little bit less than this one right here. So, you know, I think this one is more capable and it's in better physical condition. So yeah, let's get this one moved over. We'll try it out. And with any luck, we'll be in business. And this is the XG8000 end housing going on. It's actually very similar to the Predator, but there are a few extra bolt holes to accommodate the exhaust support. Okay, so the ball bearing, it bottomed out, which is a good sign. So let's get the brushes secured. We'll take a look in, and hopefully they're centered on the slip rings. All right, I think, or I hope we're going to see some brushes here that align properly on the slip rings. And yeah, look at that. So each brush is on the corresponding slip ring, and it's pretty much perfect. There's no overhang, so the brushes, they are fully where they need to be. So I think we have a winning combination here. We have the Generac XT engine with the Black Max rotor and the Predator stator. So this should theoretically work. Of course, that's assuming the engine works. So let's get things bolted down properly. We'll torque everything up, we'll get it secured, and then we'll turn our attention to getting that engine to fire up. It's nice too, they slotted the frame, so even though we're about 3/16 of an inch shorter, there's plenty of adjustments. So we could actually put a generator on here that's at least an inch shorter and not have to drill any new holes. I've got a wrench on the flywheel nut holding the crankshaft still, so that will allow us to torque this rotor down. Now this one, I believe, should be torqued to 18 foot-pounds. There's two different types of bolts that I usually see, and the smaller one is 18 foot-pounds, and the larger one is about 30 foot-pounds. And this bolt, it is actually the larger diameter bolt, but if you look down here on the threads, they step it down to the smaller diameter. So I'm going to go with the lower spec of 18 foot-pounds, and with any luck, the threads on the crank will hold and allow us to torque this properly. Nice. So that was a pretty big milestone that we got the rotor torqued down properly. That was probably the biggest reason why I declared this a parts machine. The generator was bad, and I thought, although the engine might work, we were never going to get a new generator bolted on. And as it turns out, I was wrong about that, because we do have one, and it's torqued the way that it should be. Before we go much further, it's a good idea to rotate the engine. You want to make sure that it can rotate freely, that the rotor is not scraping against the stator. So, to do that, you can take the plug out. It makes it a little bit easier. In my case, the plug is still in there, but I'm just going to rock the engine back and forth, turn it over, and make sure everything sounds good. I think we're looking pretty good. So the engine rotated fine. I didn't hear any funny noises, no binding. So the alignment seems to be good. So we get the brushes back in place. And I think I'm going to stick with the Generac AVR. You know, the AVR that was on the Predator has the same rating as far as the capacitor goes. But the Generac part just looks to be better built. But they should function the same. So we'll get that secured. And plug it into the brushes as well as the stator. Now, this stator does actually have 2 extra plugs, which we don't need on this machine. I think on the Predator, you know, one was likely to charge the battery, and the other one probably the fuel solenoid. This machine, I'm assuming, performs those functions off the 120. Okay, and as far as the wiring goes, we're not going to wire anything yet to the control panel. You know, I'm just going to add the wire block back in. We'll leave these as they are. And then once we start it, you know, we can do some testing and just confirm what we think is true, which in this case, I believe these 2 white wires are neutral, and then we have leg 1 and leg 2. So when we first start it, we'll just test these 2 separately, and then we will join the neutrals together and make sure we get 240 out. These 2 wires here, they're just connected to basically an extension cord. So, you know, when we do start this for the first time, we're just going to be doing a controlled test without sending power to the control panel. And we're also not going to wire it for 240, not yet. Well, in theory, this should make power the next time we get the engine running. That said, though, I have never had this engine running, and there are a few obstacles to getting it up and going. You know, though the engine rotates and has compression, we don't have our starter recoil, so hopefully the electric start is good. And even if it is, you know, we don't have a carburetor. We're actually missing the insulator, the studs, the carburetor, and the airbox. So I think we should probably start here. Let's get this issue sorted out, and then we'll be pretty close to first start. So after I damaged the original insulator, I went ahead and ordered a new one, as well as a new set of studs. And I guess the good news is the insulator came pretty fast, and it just bolts on something like that. The problem is the studs, they are discontinued. So yeah, that's a bit of an issue. The original studs looked like this. There were actually 2 of them. This one survived just fine. And it's really just a normal threaded bolt. But on the end, of course, they had to make it a little bit different and make this into a rectangle. So that keys in on the backside and theoretically keeps the stud from spinning. But in my case, there was some corrosion and rust on the other stud. So when I removed the nut, instead of the nut coming off, it just blew out the plastic on the backside. So what I had to do instead was actually just buy a long bolt from the hardware store, and that should go in there. It's threaded all the way down, which isn't ideal, but it should be fine. And it is a tiny bit longer, so we might have to cut it down. But I think the real issue here is that, this will not fit in place. So we do need to shave a little bit off each side to allow this to drop in place. So let's see if it fits. And it does. So I think that's the first problem solved. The gasket, it is still here and looks to be in good shape. So I'm going to reuse that. So let's get the insulator torqued down and figure out what to do about the carb. As far as the carburetor goes, I actually ordered a clone carb after I stole the OEM one off this machine. I was planning on using it just to see if we could get the engine to run. I didn't really have much concern about how well it ran. But now that we have a viable generator, I'm not sure that's the best option. Not to mention, I have a better. This is an OEM Nicky carb. These sell brand new for about $200. And this one I broke. In the last video where I worked on an XG8000, I tried to remove the pin and accidentally hit it too hard, and one of the legs broke right off. So this, at that point, was a parts carb, but one of you reached out and offered to fix it. So I sent it to you, and he actually made a video on it, so I'll link to that up above and down in the description. But what he did was he used a brass rod to build the missing leg, and now the pin, the needle, and the float seem to work like they should. That said, though, we're not out of the woods yet. We're actually missing a rubber plug right there, and without that, the carb is going to let fuel through unmetered. So that plug, it is discontinued, but I do have another Generac carb with said plug. So I'm going to try to get the plug out of here, move it on over to here, and then we'll get this OEM carb installed and give it a try. Well, I'm not 100% sure that this plug is even going to fit. This is a different Generac carb, actually for a smaller generator. And I would say this carburetor is probably 20 years old. So, is the plug going to break or just come out? And in this case, it came out pretty easily. So I don't know if that's a good thing or a bad thing. Let's see if it fits. And yeah, it fits. So get the bowl back on, we'll bolt the carb on, and I think we can move on to the electric start. So I've reconnected the ignition switch so we can shut things down. Assuming we get to that point, we can also crank the engine once we add the battery. As far as the oil goes, I did take a quick peek. There is plenty of oil, and it actually looks pretty clean. So that should be more than fine to test with. And I've also temporarily mounted the start solenoid right here. So it is connected. We've got one line to battery positive, the other line to the starter. And we also have a switched negative. That goes over here to the switch. So all we need to do is connect the negative to the battery, and we should be ready for the first start. So with this negative connected, we should be able to crank the engine just using the switch. Beautiful. So you know what's next. Let's add some fuel. We'll plug in a light, and we'll try to start it. All right, let's give this a try. I've got a light plugged in and turned on, as well as the kilowatt. So let's crank the engine. With any luck, it'll start. And what I want to see is that the engine sounds good, that the generator makes power, and that we're making about 120 volts, 60 hertz. So let's crank the engine and see what we get. Well, the good news is the engine started, it sounds good, the carb is running it pretty well, but the light, it was trying to turn on, but it just couldn't do it. So I am going to swap out the AVR. That's really the only thing we can do. So we'll take the Generac one out, we'll put in the Predator one in its place, and maybe, just maybe, this thing will come to life. So. Okay, I'm going to leave the AVR right where it is. We'll give it a quick start, and if the light stays on, then we'll bolt it down. I got to be honest, I gave this one almost a 0% chance of ever making power again. And yet, we seem to be making power, actually too much power. So we were at 158 volts out on the 120 output. So we do need to back the AVR off a bit, and there is a potentiometer here to do just that. Usually one turn gives you about 2 volts. So in our case, we need about 19 turns counterclockwise, but let's start with 10. We'll get it restarted and see what that gets us. That's 6, 7, 8, 9, 10. Again. So after making that adjustment, the voltage didn't change at all. So yeah, I was getting a little bit worried, but then it occurred to me that the AVR, at least this one and the one we pulled off, they monitor the 240 volt output. And right now we only have leg 1 and leg 2 at 120 volts each. So to get 240, we do need to connect leg 1 and leg 2 in series. So let's make that connection and we'll try it again. You know, if I'm right, I'm expecting that we're actually going to be really low voltage because I made this big adjustment. And that makes me think too that this AVR likely works because most AVRs, the default behavior is when it can't sense the output, it just goes to full power. You know, this one I'm willing to bet has a little bit of intelligence to say, I can't sense anything. I should be able to, and it just shuts everything down, which is why that light was kind of blinking. So for now, we'll stick with this AVR. We'll make the connection and see if that fixes the problem. So I will say, don't take doing what I'm doing lightly. If you do it wrong, you're going to create damage. You know, in my case, I'm going to use this test lead, which really can't handle much current, and theoretically connect it like so. And what I'm going to do is have a 3 amp fuse right in between. So if something goes horribly wrong, that fuse should blow. And quite honestly, this wire, it's so thin, it's probably the equivalent of a fusible link. It's just going to go up in smoke before anything else does. So what I'm essentially doing is creating a jumper between the two white wires on the stator, which is likely the neutral. And you want to make sure you're connecting leg 1 and leg 2 in series. Worst case, you get it backwards and you'll have nothing on the 240. So I'm also going to get a multimeter on either end and see if we get 240. All right, let's give this a try. We've jumpered leg 1 and leg 2. We're protected with a fuse rated at 3 amps. And I've also got the multimeter on each leg. You know, like this, with this connection in the middle, we should see 240 volts out. You know, of course, that's assuming I connected it right. And likely when I start the engine, it's going to throw some of these clips. So we might need to try it a couple times. But we are refueled. Everything's connected like it should. So let's give this another go. So that's kind of a mixed result. Not exactly what I was hoping for here. And I guess on the good news side, you know, connecting leg 1 and leg 2 in series didn't result in a meltdown. And in fact, we were at close to 300 volts. So the voltage, it did double, but the AVR still didn't sense the voltage. So potentially we have a problem with the AVR, but I'm thinking, you know, these connections aren't very good either. So you know, let's get rid of all this stuff, and I think we'll go all in and just jumper this properly. And hopefully at that point, the AVR will sense the proper output. Same test as last time, hopefully a different result. Nice. And that did it. So the jumper that I had originally with this thin wire, just wasn't cutting it. So now that we have a proper jumper on there, the AVR sensed the output and adjusted it down. We're actually around 109 volts this time. So that is a big improvement. So I'm thinking let's swap back on this, I would say, higher quality Generac AVR. We haven't touched the settings on this. Last time we tried it, the light would just pulsate, but it wouldn't fully turn on or stay on. So I'm thinking now that we have this in place, that problem should be solved. All right, let's try this one out. This is the original AVR. It has been reinstalled, so I'm thinking this time it's going to do a much better job than the first time we tried it. Well, it took a while, but I think we finally got here. We now have control over the voltage. We were at 121 volts, 61.8 hertz. So the generator, I would say, is good. And the engine isn't doing too bad either. It sounds really good. It starts consistently. We do have to leave the choke on a little bit. Potentially, if we add the airbox, that might help. But I don't have an airbox. So, I think we're at the point where I do need to place an order. We'll get an airbox ordered up, start a recoil. And while we wait for that, I say we put the rest of the machine back together. So let's get the AVR secured. And I think we can remove this extension cord that we have temporarily wired into it. We know it's doing what it should. So we will get it connected to the control panel. And I'm going to pull the jumper too. It's possible that the control panel is jumpered, making this connection. So we're going to have to test for that. Otherwise, we'll have to throw this jumper back in place. We'll get this old battery out. It doesn't hold a charge or take a charge, so we'll get that replaced with a new one. That one's already loose. Seems like everything on this machine has been kind of loose. We'll get the battery charge circuit hooked up. And also the electric start. So when this machine went bad, someone did spray paint a bunch of X's on it. The old Stator had it, and actually the fuel tank does as well. And the control panel got a little bit of it. So I'm not sure what we're going to need to clean this off, but we'll start with some WD-40, which is pretty safe, although it might not be aggressive enough. So if this doesn't cut it, we'll go to something a little bit stronger. Yeah, it's working, but a little slow. Let's try something different. This stuff should work, but it might work too well. We're going to have to be careful. We might just take the paint right off. All the paint. That'll do. So we know what these wires do here. We tested that earlier. And with the colors that we have here, we think we know what these are, but Never trust the colors. So I'm going to put one of the probes up in the ground on one of the outlets. We'll make sure it comes out there. We'll also check the neutrals, or what I assume are the neutrals, to see if we have a bond to ground. I've got the probe connected to the ground on the outlet. So we do get a beep there. So we have a connection on the green and yellow, but we'll check the others just to make sure there's no other connections, and there's not. So right now, this is a floating neutral, and I believe it should be bonded. So we'll have to keep that in mind when we put it back together. But let's move the probe to one of the legs and make sure we get a connection to one of them, either the red or the black, and nothing else. All right, so we're probed into one of the hot wires. Should either be the black, which is right there, or the red. And it seems to be the red. Let's just check the others and make sure. All right, that seems to be good. So I'm going to move the probe to the other hot wire. And let's check that. And we'll check that. It should be the black. And it is. Not the red or either white. Or the green. So that just leaves the neutral, which we have two of them here. So let's move the probe in the outlet and see if we have neutral on both. All right, now we're on neutral. So let's check the white wires. And we only have a connection on that white wire. We don't on the other. So that would indicate we probably need to jumper them down here. And no connection anywhere else. So let me move the probe to one of the 120s. See if we can't get a connection on this one remaining white wire. And no, nothing there. Just moving the probe to the other outlet. And nothing there. So likely the GFCIs are tripped. And I don't think these ones will reset until we send power to them. So I'm going to double check the wiring diagram and just make sure that that goes where I think it goes. You know, otherwise, if I can't find that information, we do need to open the control panel and just make sure that this other wire that is white is in fact neutral. So I went back and actually watched one of my older videos on a different XG8000 where I had opened it up to make a voltage adjustment. And from there I could see how this is supposed to be wired, at least how it was on that machine. So they actually had two jumpers running from neutral over to ground, you know, one on each neutral feed. So that combines these two neutrals to make the 240, and it also bonds the generator. So we're going to get that connected the same way. And I'm not going to tighten anything down yet. I think we're going to have to bend the wires and get them situated a little bit because the leads coming down from up above, they seem to be a little bit overly long. Why didn't you tell me? I forgot the most important wire. Anyway, I gotta redo this anyway. I want these wires to be behind the wires coming from the control panel. It's important that we get these wires held securely. You know, they can get sucked into the rotor. And of course, when that happens, it's going to destroy the power head. So, you know, I'm going to use kind of a specialty zip tie. It's really a normal zip tie, but it has this right here for the bolt. It just keeps it firmly in place. So we'll secure these extra windings down here. And potentially we could look to use those. You know, like as I said earlier, this generator doesn't charge its own battery. So, you know, if I can find the wiring diagram for the generator that this came from, you know, we might be able to make use of the extra winding. All right, I think that'll do. So I'm going to get the cover on. You know, we could revisit that later, potentially. Honestly, I'm not too worried about it, though, because usually you don't care so much about the battery charge while you're using it. Yeah, it's more when you're in storage. And this one already has accommodations for that. And now that the stator is a 1/4 inch shorter, the cover fits on here a lot better. All right, let's see if we can get the paint, at least the X off, without taking all the paint off. I was pretty certain the tank was good on the inside, but I can't get the cap off. That is not a good sign. There we go. Yeah, it looks pretty good in there. So the cap, just a little bit harder than most to get off. It was likely the rubber seal. You know, that tends to stick if something hasn't been opened in a while. But in this case, I think we're good. So we are more or less back together. I do want to try it again real quick, make sure the wiring's correct, that the light turns on, and that we can reset these GFCI breakers. Right now they look to be in the tripped position. Also, I've added a longer fuel line because the last few times I've had this running, I did have to leave the choke on. And I'm hoping if I let it run a little longer that, maybe I can turn that choke off and avoid having to go in and clean that carb again. I think we're looking pretty good. The wiring seems to be complete. We were able to reset the GFCIs without issue. And the carburetor, it's borderline. It doesn't like running with the choke fully off. After giving it a minute or so, I did turn it off and it kept going, but it was a little bit lean. So we might have to pull it off and clean it, but I'm thinking, once we add the Airbox, that might correct that issue. So for now, there's not a whole lot more to do other than wait for those parts. But I'm thinking, since the engine's hot, the oil that's in here, although it looked clean, I don't know anything about it. And it's been in there for sure, at least for a few years. So let's drain that out, make sure we have the proper oil in there. And when the parts arrive, we'll finish this up. Yeah, very clean oil. So the oil filter potentially has to be changed as well, but given how clean that oil is, I don't think this oil's been in there for very long, and likely the filter is new as well. So yeah, we'll just let this drain out. We'll fill it with some 1030 synthetic and call it good. Well, it's been a few weeks, and I've finally amassed everything I need to get this thing back to 100%. We have a brand new starter recoil, and we also have the Airbox, both the base, the cover, and the filter. So, before we can get this on the machine, I do need to do a little bit of prep work on this new Airbox because it didn't come with any of the hardware. We're missing this metal plate, the bracket on the top for the choke, and the fitting for the tank vent. So let's move those things over and then we can finish this up. So I will say, I'm kind of surprised that if you buy a new Airbox base, that it doesn't come with all the parts you need to actually make use of it. But luckily for us, we have this one, so we can just move the parts over. All right, and last but not least, the mechanism to hold the choke cable. Now this one is riveted in, so we're gonna have to drill those out, and we'll move this plate on the top and the plate on the bottom to the new airbox. That should do. So I did backtrack a bit and pulled the tank back off. You know, getting this choke hooked up and calibrated properly with the tank and the heat shield on, it's nearly impossible. Anyway, we've got the choke connected, and actually might have done that out of order. I think we need to get the airbox on first. So we'll get the breather back where it goes. Like that. And then we need to calibrate the choke cable. So we'll get it set in there and we'll snug the bolt down, but we're not going to do it all the way until we test opening and closing the choke using the knob on the front. So I want to make sure when the choke's off that it's fully off, which is the position it's in right now. So that's choke on, choke off. So the calibration actually seems to be pretty good. So I'll just snug that down. And if the calibration was off, you basically just move the sleeve under this clamp. Either pull it further out or push it further in to make the adjustment. But in this case, we're good. I think we're just going to get away with using that long stud. I think the filter still fully seats. Well, I think we're at the point where we need to get this outside. You know, we are fully back together, all the missing parts replaced, and we're making power. So Let's roll this outside and see what it can do. All right, let's give this thing a try. I've got everything connected and ready to go. Originally, this would have been a low THD machine. The last XG8000 I tested, we topped out at about 5% THD. And given that this generator was bad, we pulled it off and we put on a Predator Stator with a Black Max rotor. So I'm not expecting this one to be clean. It's probably going to be average at about 20%. So that we are about to find out. Anyway, one thing we need to keep in mind here is that this engine, I've had issues with it in the past. Actually, the last two I've tested, they've surged quite badly. And what it ended up being was that the default factory setting for the governor sensitivity was wrong. And I'm thinking we're probably going to see the same here. But we won't know until we put a load on it. So let's get the engine started and see how it does. I'm not sure what changed, but the carb is not running the engine very well. It's actually running pretty lean. It was hard to start, and if I apply the choke partially, you can hear how the engine sound changed. It's now running nice and smooth. So unfortunately, I think we need to shut it down and go through that carb again. I think I've mentioned this before, but the XG series, they are well made. They produce very low THD, at least the unmodified ones. But to service them, it's not a walk in the park. To remove that carb, we now have to pull the side panel again, pull the tank off, remove the choke lever, and eventually we'll get the access we need to get that carb off. There actually is a little bit of debris in there, so potentially that fuel line wasn't exactly clean. So that could be the issue. So I'm just going to run through the jets real quick, put it back together, and try it out. I apologize for the wind again. Probably not the best day to be working out here. I did not expect this was going to take so long. Anyway, it's been probably over an hour. I cleaned the carb, put it back on. It's running the same way. So I cleaned it again, and actually a couple times after that. Still no change at all. It's running poorly. And when I put a load on it, it gets quite a bit worse unless you apply the choke. So that tells me it's not a governor issue, it's a carb issue. And I think what the issue is that the carb is not making a good seal. When sliding the OEM carb on, the fuel fitting is hitting the blower housing and we're not actually forming a seal. So I took this carb off and thought I'd give the clone carb a try. And this one, it's even worse. It hits right here. And we're a good maybe 1/4 inch to 1/3 of an inch away. So yeah, if it could be this carb, but I guess we'll never know because I can't even get this one on there. So I'm not really sure why that would be. But I'm thinking we need to modify this to fit the OEM carb, and if it doesn't work, then we'll modify it further to fit the clone. It's very odd. Fixed. It's still running the same way, so let's try the clone carb. Well, I hate to admit it, but the clone carb seems to have solved our problem because this time the engine ran quite well. So yeah, I guess I would have got there a lot sooner if the clone carb had fit on there without that modification. And once I realized that the OEM one was hitting as well, we really had no choice. We had to make some clearance. And once we did that, we saw the OEM one still didn't work right. Anyway, my only reservation about using the clone is that, the last time I tried one, although it ran quite well, the engine fell a little bit short on its rated horsepower. I think we got up to 7,000, maybe 7,500 watts, whereas the OEM carb could get to 8,000 watts. But this one, it's not really an option. I think there is a clogged passage in the pilot system. The last time I had it apart, I sprayed in here with carb cleaner, And I should have seen a stream of carb spray coming out the little holes in the throat. And I didn't see that. So there is an internal blockage, and it's one that I can't seem to get to. So unfortunately, this is out and the clone's in. So I'm going to pause it. I'm going to get it mostly back together, and then we will finally do the load test. All right, let's try this again. I'm going to leave some of the parts off because the governor sensitivity might need adjusting. Although when I look in here, I don't think we're going to have to. Usually when we have the problem, I see that this is in the middle position. And in this case, it's already been moved out one hole. So we should, in theory, be good. So let's get the engine started and put it to the test. Oh, this time we're off to a much better start. The engine started easily. It's running nice and smooth, although it was a bit fast. So I did back the speed off. We're now running closer to 61.5 hertz. And without a load, the THD actually isn't too bad. We're at about 3.6%, which is very good. And the sine wave doesn't look great, but I wouldn't say it's terrible either. So let's bring on a 3,000 watt load and see how it does. So we'll start with 2,000 watts. No issues. 3,000 watts. Everything seems to be running just fine. And the THD came up some, but it's not that bad. It's actually at 7%. And the sine wave cleaned up. So we'll give it a few minutes, and then we'll bring the load up and go for the max. Well, it's been a few minutes, and everything's running just fine at 3,000 watts. So let's bring the load up. I'm going to swap 1,000 watts for a 2. So now we're at 4,000 watts. The engine speed's holding pretty good. So let's bring on 6,000 watts. And the engine speed is actually not great. We're at about 56 hertz. So we're kind of running out of horsepower a little bit sooner than I thought. But on the good news side, THD actually remains pretty good at 8.9%. And the sine wave as well. So I'm going to give this a couple minutes, and we'll try to bring it up a little bit more, but I don't think it has a whole lot left in it. Well, it's been a few minutes. It's holding the 6,000 watts, but I wouldn't say it's doing it very well. You know, I think we are pretty much out of horsepower, but we can validate that by adding a little bit more to it. So let's add another 500 watts. That'll bring us to 6,500. And it's doing it, but it's right on the edge of not being able to do it. Let's try 7,000. And no. Cannot do 7,000 watts. So this machine, I think, is limited to about 6,000, maybe 6,500 at best. Well, guys, I think that's pretty much a wrap. You know, this was a parts machine, and I was pretty confident it was going to stay that way once I saw all the damage inside. Thankfully, I had parts from 2 other failed machines, and we managed to piece together one complete machine. You know, this one now starts, it runs well, and it makes power. And surprisingly, the THD wasn't that bad. We topped out at about 9%. Which is better than most I test. You know, as far as the horsepower goes, we are down on horsepower. You know, 6,500 watts is really the most we could get out of it when we should have been able to pull 8,000 watts. You know, ultimately that is because we have a clone on there and it's not capable of running the engine at that capacity. Really, you need an OEM carb, which is why I tried to get this one fixed. And for all intents and purposes, it is. You know, that leg was broken off, so like that, the float and the needle couldn't do what they needed to do, and now they are. Unfortunately, there is some other internal problem here. So that carb is out. You know, we could buy a new one, but those are quite expensive, around $200 to $300, depending upon where you look. So, you know, at the end of the day, I'm still pretty happy with the way this turned out. You know, 6,500 watts is a heck of a lot better than scrap parts sitting around. So, I hope this video helps someone. Thanks for watching. All right, not quite done yet. This one really surprised me. The generator that originally was on this machine was a low THD generator. The one that's on there now isn't. Yet, when we just tested it, we topped out at about 9%. And although I wouldn't say that qualifies as low THD, it's probably better than 95% of the machines I test. So now I'm wondering, is it just a great random combination of parts? Or potentially is it the XG8000 AVR that makes the difference? So I'm going to swap back the Predator AVR onto this machine. We'll check the THD and see if there's any change. And we'll just leave this AVR here for now. We don't actually need to remove it for this test. But I will take it out of circuit. We'll unplug the wires from the brushes and kind of get this one plugged in and just let it hang out here on the side. All right, let's give this a try. Last time with the XG AVR, we had about 3.7% THD under no load. So we'll double check that. And then under a 3,000 watt load, we had THD of about 7%. So with the Predator AVR, it'll be interesting to see if either of those numbers change. So it does seem like the Generac AVR has some role to play in this, because under 3,000 watts of load with the Predator AVR, we were at around 9.5% total harmonic distortion. And with the Generac AVR, we were closer to 7%. So that is a significant difference. So I'm thinking, before we finish up here, I actually want to get the oscilloscope on the output to the brushes and just see what kind of power is being fed to the brushes with the Predator AVR versus the one that comes with the XG8000. All right, let's give this another go. Same AVR, that is the Predator AVR. We'll get the engine started, put the generator under 3,000 watts of load, and then we'll take a look at the waveform. We are probed into the output of the AVR. These are the wires that feed the brushes. So I'm really interested to see what that waveform looks like. So that kind of confirms what I thought we might see here. And that is that the AVR control of the voltage is pretty crude. It can only create one voltage. In this case, let's say 100 volts. And if the rotor only needs 50 volts, it doesn't supply 50 volts to the rotor. It supplies 100 volts to the rotor 50% of the time. And of course, that introduces noise. So that type of control, it's called PWM, or pulse width modulation. So I'm thinking or hoping we're going to see something a little bit different on that Generac AVR. So let me get the Predator one out of the way, and we'll do the same test with the XG8000 AVR. And one last time, except this time we are probed in to the Generac AVR. So that was a very interesting test. I wasn't expecting the waveforms to look virtually identical, yet the Generac AVR is clearly running this machine cleaner because under the same load conditions, we were only at 6.5% THD, whereas the Predator AVR was actually at about 10% total harmonic distortion. So, people have asked in the past, does the AVR in any way influence the power quality? And my answer has always been no. But based on the test we just did, I think the answer is now yes, but it's only a piece of a larger puzzle. Anyway, thought it'd be interesting to turn the camera back on and dig a little bit deeper on this. But now, I think I'm done.